Let's graph a polynomial given its factored form. So its factored form, again, is so nice because I can immediately see the zeros of the polynomial. Let's double check that this equal sign is true, though. Here I have p of x, which is a fourth degree polynomial. And here I see 1, 2, 3, 4 factors. So that checks out. Right? I've got 4 things that involve x over here. And when I multiply all of them through, I should end up with this. Let's double check. So p of x can be written in factored form x minus 5 times x minus 2 times x plus 3. It's a degree 4 polynomial. I have 4 factors right there. So let's take x minus 5 and x minus 2 first. This is going to give us x squared minus 7x plus 10. And now the x times the x plus 3, x squared plus 3x. Now I'm going to multiply this parentheses by the x squared. So I will get x to the 4th minus 7x cubed plus 10x squared. And now let's multiply that parentheses by the 3x. So plus 3x cubed minus 21x squared plus 30x. Let's combine some like terms if we can. I've got that x to the 4th. How many x cubes do I have? Minus 7 plus 3 puts us at minus 4. How many x squareds do we have? 10 of them. Minus 21, so we're at minus 11. And then plus a 30x. Cool. That is the same thing as p of x. So we just showed ourselves that this is a correct factorization of this polynomial. So this polynomial is going to have zeros when these factors are equal to 0. So when x is equal to 5, you're going to have a 0. When x is equal to 2, you'll have a 0. When x is equal to 0, you will have a 0. And when x is equal to minus 3, we will have a 0. So that's where we're going to cross our x-axis. Let's go ahead and plot those points. So when x is equal to 5, we're going to have a 0. So I plot a point right there. X was 2, we have a 0. X is 0, we have a 0. And x is minus 3, we have a 0. Right, it's a 4th degree polynomial, so I could have 4 zeros. And in fact, I do have all 4 zeros. All right, that's us using the roots, right, the zeros of the polynomial. What about the y-intercept? Well, the y-intercept is when your x value is 0. And you can use either form. Let me clear off some space here. You can go back to the standard form of the polynomial, or you could use the factored form. Either way, you'll get the right answer. So p of 0, if I plug 0 in for these x's, either way, I'm going to find out that I have a y-intercept of 0. And that checks out because that's where we cross our y-axis. Okay. So we took care of the roots, or the x-intercepts. Those are the same thing. We took care of the y-intercept. Now the end behavior. Again, the end behavior of a polynomial is entirely dependent upon the leading coefficient. This is a degree 4 polynomial. That's the highest power of x's. And the coefficient in front of that is a 1, so it's positive. So it's going to have even behavior, and it's going to be concave up, which is exactly what we see.